Alrighty, welcome to Desmos. I'm going to show you a little bit about this graphing calculator. Once again, click on this wrench and you will see radians or degrees. I want you to stay in radians. It's not hard to do, and you'll see how quickly you can get a great understanding of how these waveforms work. In here, you type in any wave you're going to graph. So if you type in y equals sine t, it puts it in like that. It automatically sets a range. We don't have to play with any of that here. If you want to make alterations under the wrench, you can change your range, how many steps, whether it puts a grid on. Don't worry about any of that. We're only interested in this as it can help us for sound. I said I wanted you to put 2 pi in here because we're dealing with radians. Notice where it's crossing the axis here. The 0 is magically, if I keep zooming, crossing pretty much at 3.4 minus, because pi is not exactly 3.14. That's it. Leave it in radian measure, but we want to force cross on the unit. And that's why the pi comes in. You can't see my keyboard. I'm literally typing the number 2 and then P and I. And as soon as you do the P and I, you saw it change to the actual script for pi. What's happened now? I use my scroll and I zoom in, and you see what's happened? The wave ends perfectly on number 1. Think of a circle, 2 pi r. In fact, I could change this to the letter r. Desmos doesn't care. And now you can see that by the time r is equal to 1, the sine wave has gone full circle. Quite literally, not a metaphor. It has fully gone circular. So this is how we can set up a really cool, very simple sine waves that sound somewhat flute-like when you play them on another program. So let's just keep it t for now. What happens if I want to divide this by something? I'm just going to go divide by 6. And you see what it did? It divided the entire sine by 6, everything on top. So that 6 is not include 2 pi t. You can't be vague like that. I'll hit backspace. I want to forcibly include the divide by 6 inside here. So I put in a bracket, I hit N to go to the end of the line. Now I go divide by 6. Aha! That is very different. I can use the right arrow, move over, end my bracket. Now, the wave takes considerably longer to complete. The wave, exactly 6 units to complete itself. This is very powerful in terms of graphing. I shall give you another example. Again, if you do sine 2 pi t, you get this. If then you decide to go divide by 6, that is not the correct one. You notice the difference between the upper and the lower one. If I suddenly decide I want to multiply by another wave, I put a bracket here, I go back, I put a bracket here, and let's suppose I wanted to multiply the equation above. Well, all you have to do then is select and copy and paste it right there. Now you've got the multiplier by the 2. Oh, but wait a minute. The first equation's in my way. It's blocking my view. It's in the color red. If I click it, it goes away. Now you've multiplied it. What if I did do something really weird and decide to do t squared on the end? I'm going to multiply it by t squared. I'm just curious. Whoa! What's it doing now? It's gone mental. That's just pretty smaller. I'll to the 0.9, 0.8, whatever. Okay, that's awesome now. And you can just play with this equation and add or subtract things. Now I'm going to go back here and take all this gobbledygook out. There's the wave. I'm going to display this one again. But I want to see them next to each other, but not on top of each other. So you remember your intercepts in formulas, like your y-intercept? If I just put a +5 here, it'll shove the whole equation up the y-axis by 5. So you can play around, throw the equations on, slide them up and down from each other, play with multiples, and you will be able to do in 15 minutes more wave plotting than students used to be able to do in a full freaking day. So this is really powerful, and I want you to try all the exercises I put up for Desmos. Watching me do it will not remotely stick in your brain as much as doing it yourself. So Desmos is going to make a huge difference in replacing the labs. Then you follow through with the online synthesizers, and you will have a rich experience that will be ringing in your ears for a long time. And finally, the capability of making incredibly annoying music to drive your parents crazy with later on this evening. So I want you to play and play and play until you start to get a natural feel for these waves and what happens. And as the last little bit, what if I change my mind and I want to add these waves together here? Then I just put in a plus sign. Bingo! It's totally different. So you got lots of room to play and graphing like at a speed you couldn't possibly conceive of. So please do the exercises I asked for so you get an innate feel for these waves.